So for example 3, we're going to verify the identity tangent of x plus cotangent of x equals secant of x times cosecant of x. This is a little more challenging proof because we start with a sum of two trig identities and we have to end with a product. So somehow we have to get these added together to be one product at the end. I'm going to start by subbing both of them out for the quotient identities. Tangent of x equals sine of x over cosine of x, and cotangent of x equals cosine of x over sine of x. And the reason that I picked that as my first substitution and my first step is because I'm thinking if I'm going to get them added together to be one thing, the easiest way would be to add fractions together. So if I have the fractions, then I can work on getting a common denominator and add them together to be one fraction. So that's what I'm going to do next. I want them to have a common denominator. And because I have a cosine of x on the bottom there and a sine of x on the bottom there, my common denominator is just going to have to be a combination of both of those things. So in order to get cosine of x, sine of x on the bottom here, I'll have to multiply by cosine of x over cosine of x on that one. And in order to get it here, I'll have to multiply by sine of x over sine of x on that one. So that leaves me with cosine of x over sine of x on the bottom there, sine of x over cosine of x there. So I do have my common denominator. And the top would be sine of x plus cosine of x cosine of x. My next step, I'm just going to clean that up a little bit. Sine of x times sine of x, you can write that as sine squared of x. Cosine of x cosine of x, you can write that as cosine squared of x. So now I'm going to do another substitution. I'm going to look at my green sheet at the three categories where we're focusing, and the top, sine squared of x plus cosine squared of x, is actually exactly what the first Pythagorean identity is. And on the top, that actually equals 1. So I can sub that out, the whole top, and I can say that equals 1. Now, when you have two things multiplied together in a fraction, you can actually break this fraction apart into two separate fractions. So instead of 1 over cosine of x sine of x, I'm going to write it like 1 over cosine of x times 1 over sine of x. I can break that up. These are both fractions. They show up in the reciprocal identity section. 1 over cosine of x actually equals secant of x, and 1 over sine of x equals cosecant of x. And that was my goal, so I am done.